Good morning, everyone. This is Mr. Parks. Today, our lesson is I can identify the multiplicity of a polynomial function written in factored form. So we've talked about what it means to be factored form already. That's when you have the linear factors like x plus 2, x minus 3, 2x plus 1. So that's what it means to be in factored form. But we have not talked about multiplicity. So our focus today is going to be over the word, mostly multiplicity. What does that mean? Bell work, if you go out there and you do the Desmos that I have assigned out there, I highly recommend you do this. It'll help you with your learning. If it'll load. Okay, so it helps you sketch some graphs and work with polynomial functions. And the page I'm about to go over is this guided notes page. Notice it's only one page. And then you have practice that's through Desmos. And so on Desmos, this is more of an activity to kind of help learn it yourself. But the skill today is to find the multiplicity of a factored polynomial. And notice the first thing they ask you to do is factor. So I will show you how to factor that. So I will factor this problem. And I will factor this problem for you. And I didn't even see this one until just now. I also need to factor that problem for you. Let me write that down before I forget. Factor 2x to the third minus 3x squared minus 18x plus 27. Okay, so we're going to spend time on how do you factor that, just not today. So, and then notice this one's already in factored form. And this one's already in factored form. What's different is it has an exponent. And we're going to talk about what that exponent means. Long story short, it just means that it's a multiple zero. It happened 5 times. This one happened 6 times. Okay, so this is an exploration activity. But let's go ahead and get started with multiplicity, and then I'll factor those. I believe it was 4 functions. So how do you find the multiplicity? So the word multiple zero means a zero that is repeated. Okay, so we get the word multiplicity of a zero, and all that is the number of times the linear factor is repeated. And what it does on the graph is it impacts the behavior. It determines if it's going to cross the x-axis or if it's going to like bounce and go back up. So here's an example. Find the zeros. So to find the zeros, I would set this equal to 0. And then notice it's already factored for us. Notice I have a repeated 0. We call that multiplicity of 2 because there's 2 of them. And when I can use the zero product property when there's 3 terms also. So if you're multiplying 3 terms together and you get 0, then either this is 0, or this is 0, or this is 0. So I would set all 3 equal to 0. If I set x minus 1 equal to 0, I'd get x equal 1. if I set x plus 2 equal to 0, and I subtract 2 from both sides, I get x is negative 2. And then, of course, if I do x plus 2 on this one, I get negative 2 also. It's the same thing. So what I want you to notice, that this polynomial had 3 factors. That means it's going to have 3 solutions. So notice that while the function has 3 total solutions, only 2 of them were unique. This should be THEM. Only 2 of them were unique. We have 1, we have negative 2, but negative 2 actually occurred twice. Okay, so negative 2 is listed as a 0 twice. When a 0 and its linear factor is repeated, it is called a multiple 0. Notice we put the definition of multiple 0 on top. In this example, negative 2 is said to have multiplicity 2, since it occurs as a 0 twice. So let's say I had negative 2, negative 2, negative 2. Then I would say negative 2 has a multiplicity of 3 because it occurred 3 times. So that's all multiplicity is. How many times does that 0 happen? And when you have multiplicity, that does change the graph. I don't want to ruin it for you. That's Desmos activity. But it does cause different things to happen around the x-axis. In general, the multiplicity of a 0 is equal to the number of times the 0 occurs. So here's an example, and notice number 1, this is not in factored form, so I will factor that for you. You guys do not know how to factor this yet, so for now I'm not asking you guys to factor. We're just talking about what it means to be multiplicity. If this f of x confuses you, that just means function. So this function is called the f function. To find the values, just plug in for x. Some people just like to think of this as the output. So like the y, this is the input. So if I find the zeros, I need to set this equal to 0. And I might go through this part a little faster because technically you don't know how to do this yet. But when I look at this, the first thing you always look for is a GCF. And I see 168, no GCF there, or I should say no common factor there. But I do see that they all have at least an x squared, so I'm going to factor that out. And then take out x squared from each term. And now you should know how to factor this. And I probably won't make the x, but I need 2 numbers that multiply to 8, but add to 6. That'd be 4 and 2. So I get 0 is x squared, x plus 4, x plus 2. So notice the only thing new here with the factoring was the fact that there was a GCF. And once you factored out the GCF, you should know how to factor these. So find the zeros and its multiplicity. Well, this is like x and x. So actually, let me rewrite that. So this is the same thing as x times x plus 4 times x plus 2. Because the x occur twice. So when I set this equal to 0, I'd get x is 0, x is 0, x is negative 4, x is negative 2. Okay, so I would say, kind of ran out of room here. I would say x equals 0 is a solution, multiplicity of 2. And then I would also say that negative 4 is a solution. And I would say that negative 2 is a solution. And now how many times do they occur? They occur once. You could say multiplicity of 1, multiplicity of 1. Usually when the multiplicity is 1, people don't list it, but feel free to. Okay. All right, next one. Find the zeros. Well, when is this equal to 0? It's already factored for us. But to find the zeros, I set it equal to 0. For 5, x minus 5, I get x equals 5. Multiplicity of 1. And I mean, I kind of get tired of spelling out multiplicity, so I totally understand if you use m equals. So multiplicity is 1. Here, solution is x equal 4. How many times does 4 count as a solution? Twice. So the multiplicity is 2. Here, what's the solution? Negative 1. Negative 1 plus 1 is 0. So I get negative 1, and it occurs twice. This part right here, the y-intercept, we're not going to worry about that right now. Let's see what someone said. It's 3 times for the middle one. Thank you. So yes, I copied it down wrong. X minus 5, x minus 4 to the third. Okay. So x minus 4 would be the solution for, this should say multiplicity of 3. Thank you. Okay. A new one. State its degree. Well, you can't really state the degree when it's not in standard form. And the leading coefficient, and describe its end behaviors. You know, I guess we could go ahead and do the y-intercept. The y-intercept would be, once you multiply all this out, it would be negative 5 times negative 4 to the third times 1 squared, because your constant's always the last of each when you factor it. So the y-intercept would be negative 5 times negative 4 to the third times 1 to the second. Let's see, I'm going to type that on my calculator. That's 320. Okay. All right. And all I did was I took this part. I took this part, and this part. So a new one. Sketch this, state its degree and its leading coefficient, and then describe its end behaviors. So for the sketch, I'm okay with you just typing that into Desmos. So let me go and go over here to Desmos. Look, I already typed it in. So here's what it looks like. So notice I have 1 is a solution. I have -2 is a solution. And see how it kind of bounces right there? See that? It doesn't just go through, it just kind of goes, bounces. And then I have -5 as a solution. And again, it kind of does a little bounce there. So anytime there's multiplicity, it does a little bounce. So this is what the graph looks like. And if someone asked you for end behavior, you would say it goes down on the left and it goes up on the right. I know it's kind of hard to see, but it goes, reaches its max, comes back down, crosses. Actually, I think I have that backwards. This one's really hard to see. So if I look at this, and I'm not going to draw a rough sketch just for time's sake. So if I want the number in the very front, that would be the leading coefficient. So if I'm going to find the leading coefficient, I would take 5 times 1 times 1 times 1. So I would say the leading coefficient is 5 times 1 times 1 times 1. And it's actually 5 times 1 to the first times 1 to the third times 1 to the third, but that doesn't really matter because 1 to the third is just 1. So if I multiply all that out, I just get 5. My leading coefficient, remember, you look to see if it's positive or negative. Well, 5 is positive. So what does that mean? It means it goes up on the right. And so the way you would write that is as x approaches the right, the function, we'll just say y goes up. So as we go to the right, we go up. That's what that means. Okay, now we got to see what the left side does. The left side, we need that degree. Well, you just add up all the exponents. So degree, here I'll do that in, so the degree, 5 has a degree of 0. So then we have x to the 1, x to the 1. Actually, it's x to the third. So we got x, x to the third, x to the third. So again, that's x. Got x to the 1, x to the third, x to the third. So 3, 6, 7. This would be 7. So the degree 7 is that odd or even. We would say that this is odd. So what does that mean? It means whatever it did on the right is going to do the opposite on the left. How would I write that? I would say as x approaches the left, the function, which in this case is just y, the y goes down. Okay. That's how you write that out. Okay. So that is multiplicity. The activity for today is just typing things into Desmo, seeing what they look like, kind of making your own. It's a good activity, so please make sure you do it. But just to make sure you could do the Desmos, remember there was 2 or 3 of them that needed factored, and you guys don't know how to factor higher degree polynomials yet. So I'm going to show you this real fast. And we're going to go through all this semester. But notice we call this higher degree. And you don't have to understand this part. I'm going to go through this part pretty fast, but you will have to understand this eventually, so just try to pay attention. Well, we call this a higher degree polynomial because it's to the third power. And we have 4 terms. First thing I look for is a GCF. No GCF. So when you have 4 terms, a strategy is to try factoring by grouping. That's where you cut it in half. And then you look at the left side and you say, what's the GCF? Well, the GCF over here is x squared. And then what's left over would be x minus 2. And then you look at the right side and you say, what's the GCF? Negative 4 and 8 would be negative 4. You always factor out the negative. What's left would be x minus 2. So this is called factoring by grouping, and we'll do examples like this together. So I have x minus 2, that's the same, so I factor that out. And then I have x squared minus 4. And then you should know how to factor x squared minus 4. That's the difference of 2 squares, x plus 2, x minus 2. So we got x plus 2, x minus 2. So if I'm going to rewrite that, I would say x minus 2 happens twice times x plus 2. So the first one in Desmos on that practice, I mean, I did the work for you because you guys didn't know how to do that yet. Okay. So just want to make sure you guys see what I'm talking about here. So on Desmos, your activity, Alice, the first one, it says factor. Well, you guys don't know how to factor higher degree polynomials yet, so I did that part for you. So it's in the video if you need it. I'll put this recording out there. I do need to factor this one for you too. So I'll do that real fast. Here, I look for GCF and I say, hey, they all have an x squared. So I factor out the x squared. And that leaves x squared plus x minus 6. And then you should know how to factor this part. What multiplies to negative 6 but adds to 1, that'd be 3 and negative 2. So then this would be x squared, x plus 3, x minus 2. And notice I didn't put the factor x on it. You really don't need to do that to show your work anymore. We were just doing that so I can see what you were doing. So 3 times negative 2 is negative 6. 3 plus negative 2 is 1. So I factored this for you. There was another one that needed factored. And this one's very similar to the one I just showed you. There's no GCF. There's no x's in all of them. So you take it and break it in half. This is called factoring by grouping. You look over here, what do they have in common? They have an x squared in common. What's left over? 2x minus 3. Over here, you factor this GCF. The GCF is 9. So I factor out the negative 9. And that leaves negative 9 times, that leaves 2x. And then negative 9 times negative 3 is 27. I get the same thing on both sides. I factor it out. And then I get x squared minus 9. And then x squared minus 9 This difference of two squares makes x plus 3 x minus 3. And again, we will spend time practicing how to factor by grouping on another day. So if I went through that too fast, it's okay. Okay, you're not responsible to know this yet. Okay. Next, and that's our last one I needed to show you, or was that our last one? Maybe that was our last one. Thought there was one more. Let's see. So I factored that for you. I factored that for you. And then I factored this for you. This one's already factored. This one's already factored. Okay, so you should be set. Because I did the factoring for you, I do expect that you at least copy down what I did right there when you turn this in. But other than that, that is multiplicity for you. It just means that the zero happens more than once. That's all it means. So multiplicity could be any number. Multiplicity will never be negative. Okay, it'll never happen a negative amount of time, so be careful with that. Multiplicity is always positive. But other than that, that is all I have for today. Hope you have a good day, and I'll see you all later. You could sign off. Bye-bye.